Hi, I recently posted a video to help my students out writing a design specification for GCSE Electronics. If you watched that video, or maybe if you didn't watch the video because it was too long for you, I thought I'd do a shorter, more focused video focusing on design specification points for flashing and buzzing. I'm going to do a little review of some general advice, but then I'll give you some specific examples, and hopefully the video is going to be shorter. Okay, so my general advice is only focus on matters that affect function and performance of your electronic circuit. It is electronics. We're not doing home economics. We're not talking about like what we could possibly buy off eBay or what stuff we might be able to put in our circuit from the point of view of components. I mean, we're thinking about function, hopefully. Saving the world is an admirable thing, and caring for the environment is definitely a good thing. But bear in mind that this is electronics, so we should be thinking about, in my opinion anyway, we should be thinking about the function. If somewhere you want to put some points about, say, the performance from the point of view of like energy saving, that would be entirely appropriate. But let's not just think about like points like recycling components. So if you put that as a specification point, that your product will contain recycled components, I'm not sure that is something that's really suitable. Okay, right. Okay, so a specification should be specific. So don't add anything that's subjective, like it will flash quickly, because what on earth does quickly mean? Okay, that's going to be very subjective. In other words, down to personal opinion. So what you want is to avoid being subjective. You want to be the opposite, which is objective. So not open to personal opinion. So that could be qualitative or it could be quantitative. Now, the qualitative things are functions and features you can just list off. Like, for example, the light will flash. Okay, it either will or it won't. So if it does, then you meet that point. So you can be qualitative, just like something being there. Okay, you could also be quantitative, give something that's measurable, like saying the light will flash at 2 hertz, 2 times a second. So once again, they're objective things. It's not personal opinion. It either flashes at 2 hertz or it doesn't, or it flashes or it doesn't flash. Okay, so up to you. Don't make a shopping list. So don't say in your specification, design specification, just to hit the number of specification points. Don't just say I will include an LED, I will include a buzzer, I will include a thermistor, my product will run from a 9-volt battery or whatever. Possibly from a 9-volt battery, one might be all right. But don't just like list off components thinking that you're going to somehow meet the specification point. So don't do any of those things. On the other hand, you should specify, what function it actually performs and to what standard it performs. Okay, we'll come up with some examples in a moment. So the sorts of things that if you were doing something that flashes and buzzes, flashing like LEDs or lamps or whatever, and buzzes, maybe loudspeaker or buzzers even or whatever, the things that you could specify are the frequency at which that operates, the duty cycle, and I'm going to give you some examples of that in Circuit Wizard in a minute. And duty cycle we could also refer to as mark space ratio. If you don't know what I'm talking about, Google that one, mark space ratio. Whether something is periodic, so it's not happening all the time, or whether it's happening all the time, in other words, it's constant, or whether something happens at, say, a fixed frequency, or that frequency varies. All of these sorts of things you could include in your specification. So, for example, these ones are fairly basic. The LED will flash at a constant frequency, you could say. So you're not actually naming or specifying the actual frequency, but you're saying it's constant, so we can measure that. Is it constant or is it not constant? So it's not subjective, it would be objective. You could also say that it would flash at a variable frequency. So that's not going to be subjective. It either maintains the same frequency or it doesn't. So if you say it's variable and then you make it variable, then you've met that point. You could be specific and simple. You could just say the LED will flash at 1 hertz. That's easy to test as well. We could use an oscilloscope. We could say the LED will flash at 1 hertz with a 20% duty cycle. I'm going to show you an example of that. That just means that it's going to flash on off and it's going to repeat that every 1 second, but only 20% of the time would it actually be on. You could say the device would play a tone between, and then you can give frequencies as well. So, and you can do that for music or tones that you're generating. You won't be able to do that, say, for most buzzers because they're going to have a fixed frequency. So if, for example, you are using a fixed frequency buzzer, you might not want it set to sound all the time like zzz, like that. You might want it to go zzz, 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 or whatever it happens to be, okay? So you could, a specification point that would be good would be to say the fixed frequency buzzer will sound periodically, that means not all the time, and then specify a frequency and specify if you wanted the duty cycle. If you don't specify the duty cycle, I think it would generally be taken for granted that it's going to be 50%, like 50% of the time it will be on, 50% off. You could say an LED will flash at a constant frequency, but with a variable duty cycle. So then the frequency of 1 kilohertz never changes, but the amount of on time is variable between 10% of the time and 90% of the time. Okay, so they're all perfectly valid. Okay, let's just quickly look in Circuit Wizard just in case you're not sure about some of the stuff. So I've just got function generators set up for the moment, and you'll see I've got a probe on this one. And hopefully you'll see that for every 1 whole second, like between 2 and 3, it was on for 1 or 50% of the time for half a second. Okay. So without changing the frequency, and by the way, you could just change the frequency by just changing the frequency like this. Let's just do that. You see? Okay. So now, yep. So we got on off. So on-off and on-off happens in one second. In other words, 2 cycles per second. But let's just change that back to 1 second, 1 hertz rather, 1 cycle per second. So we're now, and we can just clear this and just start this again. Okay, so it's going to be on for 1 second, off for on for half a second and off for half a second. Okay, 1 hertz. And what we could do though, let's just move this probe down here. We could actually change the duty cycle. So for example, and let's try it now, we won't have changed the frequency, but you'll see that this one only blips on for like a tiny proportion of the time. So they're exactly the same frequency, still 1 hertz. So it goes through 1 whole on-off cycle 1 time a second, but only 5% of the time is it actually in its on state. So that would be a 5% duty cycle, which would be the mark is 5% of the time, the space is 95% of the time. Okay, so hopefully that's given you a bit of a clearer idea about your design specifications, specifically for things that buzz and flash, or flash and buzz, or something else even. Okay, it could be motors as well, turning on and off, or whatever you want to do. Okay, so if you're one of my students and you're looking for design specification points, by all means have a look through this video again. Don't copy anything word for word, it's got to be your own work, and I look forward to seeing it. Okay, hope you found the video useful. Oh, by the way, thumbs up if it's good. All right, thank you.